All right, I have a question for you, and it was sparked when I went to Joel Groover's place, and he talked about the radishes actually making more nutrients available. And interestingly enough, in one of my farmer's corn crops, at the end of his corn crop, he had more phosphorus, more calcium, more magnesium, more manganese, more zinc, more copper available in the soil than before his crop started. And this blew everybody's minds away. We couldn't, a lot of people couldn't understand, and a lot of people were incredulous, and we said, but we had only 5 points, but the data came up each time that's what was happening. Could you explain to us what's happening? You know, you wrote the paper with, was it Dave White about
it was Charlie White.
Charlie White, excuse me.
Charlie was a grad student of mine.
So what is happening? I mean, we're not manufacturing phosphorus and potassium, but what is happening in the soil that's making phosphorus and potassium and these minerals more available?
So, you know, the more we learn about this, the more we realize that this whole system is just a very complex and intertwined system. And in the past, we've tended to look at the parts. So we looked at the corn plant, and it's like as if it were by itself. Here's the corn plant, and it's taken up nutrients, and therefore there has to be fewer nutrients left in the soil, right? And on a total basis, that's true. If you remove nutrients in the truck that you sent to the market, those nutrients are gone from the soil. But most of the nutrients in the soil are not in this available form that either soil tests measure or that plants can use. Most of them are locked up still in the minerals in the rock that will take, you know, ages for them to slowly be released. So there's an enormous tonnage of potassium and iron and even copper in this soil. In only small amounts being released at a time. But the plants facilitate that. So they're not just sort of dumb, blind actors in this where you're putting them in like in a hydroponic solution and you're feeding them. No, they're communicating. They're sort of cheerleading this whole group of microorganisms. They're feeding them. They're sending signals out. There's all of this talk going on, not by voice, but by chemical signals. Between plants, between the organisms that grow in the rhizosphere of the plants, between different organisms. And so the plants are capable of enlisting microorganisms in this, and they also produce chemicals which react with the minerals in the soil and the organic matter and speed up the release of nutrients. So the plants are causing the nutrients to become available for them. Some plants do this better than others. The radish, because it does not form a mycorrhizal association with fungi, so I think almost all of the other cover crops here do that. Most of our crops do that, everything except maybe radish and sugar beet and spinach, and there's 1 or 2 others, that family. The beet family and the radish family are really the only 2 families that don't do this. So they have to have their own way of getting nutrients out of the soil, and so they exude organic acids, some specific organic acids which can break the binding of phosphorus, for instance, with iron. So in these soils, most of the phosphorus will be tied up with iron that gives the soil a red color, or in the organic matter. And they have enzymes like phosphatase which breaks that off, so that the roots are exuding chemicals that then release the nutrients into a more soluble form and can increase the soil test. We showed that very clearly. Now in the case of the paper you're referring to, we did not harvest the radish. The radish died and remained in place. So all the nutrients it took up were then concentrated around the radish hole, and we showed that this was a real hot spot. But you can, if I analyze just the soil in these channels that the earthworms and the roots have made, they'll be much higher in nutrients. So it's a very nice place for plants. If I take a soil test, I'm getting the average. Mostly it's this kind of stuff.
Right.
But the roots are actually seeking out these high nutrient places. So your soil test is getting an average of all the low areas, and the plant is purposely finding the high areas. Okay, so in that sense, the soil test has to be interpreted with caution. So that's how you can get these sort of results that seem like a paradox.
Right. Okay. Well,
does that make sense in terms of why you might end up with a higher soil test level after your plant has taken all these nutrients out?
That's a great explanation, and I intend to do a little bit more work.
Okay. And this is something that is not heavily researched yet. I mean, and you know, so we're all still learning this together.
Well, it stands to reason that cash crops might be doing the same.